Sony Semiconductor is reportedly preparing to mass-produce a groundbreaking full-frame 4K SPAD sensor, complete with global shutter and their advanced two-layer transistor pixel technology. This development has sparked excitement, especially among filmmakers hoping for revolutionary image quality. But alongside the buzz comes a dose of realism. While the SPAD sensor sounds like a major leap forward, its practical limitations raise serious questions, especially around whether this tech is destined for the upcoming Sony FX3 II. SPAD sensors are unique in how they work, detecting individual photons using principles similar to LiDAR. This allows for extraordinary low-light sensitivity and the coveted global shutter effect, which exposes all pixels simultaneously. That's a game changer for motion-heavy scenes, eliminating the rolling shutter distortion that plagues many cameras today. For action filmmakers or drone operators, the idea of a full-frame SPAD with global shutter is undeniably appealing. But the challenges are substantial. First, there's the issue of power consumption. A full-frame SPAD sensor operating at 4K demands much more energy than current compact cinema cameras can provide. Devices like the FX3 are built for handheld shooting, portability, and efficient battery use, conditions under which a SPAD sensor would struggle. Then, there's the cost. Manufacturing a 24-megapixel global shutter sensor is prohibitively expensive, with estimates suggesting the sensor alone could run around $6,000. That's far beyond what the FX3 II market would support. So, what is the FX3 II likely to feature? All signs point towards Sony's EXMO-RT sensor technology. This two-layer design separates the photodiode from the transistor, improving readout speed, noise handling, and dynamic range. It doesn't offer global shutter, but it significantly reduces rolling shutter effects, which is a notable upgrade for filmmakers. More importantly, it fits well within the FX3's identity as a compact, accessible tool for creators who value quality without the burden of high costs or excessive power demands. Beyond cost and power, SPAD sensors have inherent limitations. Due to their photon counting design, they need to reset frequently, during which they cannot register incoming light. This reduces their effective quantum efficiency in standard photography or videography. While they're unmatched in scientific or depth sensing applications, they're not yet optimized for typical imaging needs, particularly in consumer or prosumer products. That's why many believe the SPAD sensor is better suited for Sony's higher-end cinema cameras like the Venice series or a future FX9 successor. These cameras already cater to top-tier productions, where power supply, weight, and cost are secondary to image performance. The Venice lineup, often used in Hollywood with setups like the Rialto extension, would benefit immensely from global shutter and the high-sensitivity SPAD promises. But even in that realm, we're likely years away from seeing a ready-for-market version. As for the FX3 II, a global shutter sounds futuristic, but doesn't align with its intended audience: solo shooters, indie filmmakers, and content creators looking for reliable performance in a small, affordable package. Sony has always balanced cutting-edge features with user needs in the FX line, and an Exmor-T upgrade would be a logical, meaningful step forward. It improves low-light performance, speeds up data readout, and cuts rolling shutter, all without the trade-offs of an experimental sensor. In the bigger picture, Sony's exploration of SPAD technology signals an exciting direction for the future of imaging. But for now, it remains a glimpse into what might come years down the road. The FX3 II will almost certainly focus on real-world improvements that matter today, building on proven tech rather than betting on one that's still finding its place. As much as global shutter excites tech fans, smart incremental evolution with tools like Exmor-T is what will continue to empower creators in the immediate future.